In this video, we are going to see how to graph linear inequalities. We graph first order inequalities such as y less than or equal to 2x minus 3, 2x minus 3y greater than 5. Graphing inequalities is similar to graphing equations. When you are graphing equations, we have to remember two important things. Suppose if you have a borderline like this, then this line divides this whole plane into two halves, one lying to the right of it and the other one lying to the left of it. So the blue shaded one is the right half plane and the other one is the left half plane. Now in this case, if the boundary line is a tilted line, inclined, then you'll have a region lying below that line and a region lying above that. So it is the lower plane and that is the upper half plane. When you have a horizontal line, then it is easy for us to find what is the upper half and the lower half. So here we have the borderline to be the equation y equal to x minus 2. The region lying above will be the upper half plane, lying below will be the lower plane. So if I can take any point, say 4y here, when I plug in the value, in this case, this result will be when x is 4, 4 minus 2, y equal to 4 minus 2 is a point on the line. But when I take 4 minus 2 here, this point will satisfy less than, because whatever point I take here, it will be less than 4 minus 2, which is 2. And here all these y values will be greater than 2. So you know that this is the upper half plane and the other one is the lower half plane. Now suppose if I am trying to find the inequalities, say replacing this equation y equal to x minus 2 by greater than, strictly greater than or equal to, less than or less than or equal to, then the equation becomes these four: greater than, strictly greater than, greater or equal to, strictly less than or equal to. And the diagram may look like this. Now see here in the first case, when it is strictly greater than, the border line is drawn using dotted lines. It is not a continuous line. So if it is not equal, then use dotted lines. If it is equal, then use border lines for this. So these two are upper half plane. So you are shading the upper half plane, but the difference is only the line. Here the line is not included. Here the line is included. Here the region above the line. Here it is the region above the line as well as the points on this line. To graph the next one, it is the lower plane, but when it is strictly less than, you use a dotted line. When it is less than or equal to, you use a bold line. The graph of each of these is the upper half plane, excluding the boundary line for greater than or less than, including the boundary line greater than or equal to, less than or equal to. When it includes, use bold lines. When it doesn't include, use dotted lines. So you can also graph this using our graphing calculator. When I enter this equation y equal to x minus 2, I can move my cursor to this left corner and then change these symbols using the enter key. Change this symbol. So this is there is a line and you have region above this. So this will tell me that I'm selecting the upper half of it. So when I press that, I can get this region. See here, I get this region. So you decide whether you are going to use a dotted line or a bold line. Use a bold line if it is greater than or equal to, dotted line if it is strictly greater than. The same way, to do this one or this one, that is in the lower plane, in your calculator you select the region lying below the line. See, there is a line and you have a region lying below this. So this is the lower half. Again, you decide about the dotted line and the bold line. The bold line if it is less than or equal to. If the equality sign is there, always bold lines. If the equality sign is not there, always dotted lines. Graphing a linear equality, say 2x minus 3y less than or equal to 6. First of all, we have to rewrite that as y equal to something. So we know that it is a solid line, and also we graph that solid line with a solid bold line. And you have to test use a test point above or below. If you are doing it manually, you use a test point above or below, then check whether that value is true for the given statement. If it is true, then use that region as the half plane. The region containing the test point will be the half plane, which is the solution to the set. For example, if I take the test point as 0, 0, and in this case 0 is less than or equal to 6 is true, so I will use only the shaded, the portion which involves 0, 0. For example, so you have this line 2x minus 3y less than or equal to x, and when you rewrite this as y greater than or equal to 2x minus 6 by 3, or I can draw the line y, this white line here is y equals 2x minus 6 divided by 3. I'm using a bold line here because it is less than or equal to. Now I'm taking a test point here 0, 0. When I substitute this as a test point here, x is 0, y is 0. 0 is greater than 0 minus 6 by 3. 0 minus 6 by 3 is negative 2. And 0 is greater than negative 2 is true. So you use that test point to be a point in your selected region. So I have to select the region which involves my test point. So this will be my upper half plane. Even if I do not have an idea of upper half plane and lower half plane, I can still do it manually without using my graphing calculator and by just using the test point. Now, whenever you use the graphing a linear inequality, these are the steps to remember. First, draw the line. Here I am considering a bold line because the less than or equal to sign is there. Then I select a test point and check whether that statement is true. If the statement is true, then that half plane should contain 0, 0. So I am going to shade that again. So these are the 3 steps to follow. So when you follow that, you will get a region like this. Suppose if I want to graph y greater than negative 3, then I have to graph the line y equal to negative 3 with a dotted line because it is strictly greater than. And I may take a test point and check whether it is true. Here x is 0, y is 0. 0 is greater than negative 3 is true. So I shade the region which involves 0, 0, which includes 0, 0. So the graph of this line is going to be a line like this. And then shading the region includes the point 0, 0. So the second diagram will be the answer to this question. The same way, if I am trying to graph 2x less than or equal to 5, first I have to graph the line x less than or equal to 5 by 2. So that must be a solid line because it is less than or equal to. Then I take a test point and check whether it is true. If it is true, then I'll be using that region. 0 less than 5 is true, so I'll be using that region as my answer. Now to graph this linear inequality, x less than or equal to 3y, first we have to graph the line x equal to 3y using a bold line. And then I have to select a test point. Here I cannot select the point 0, 0 because 0, 0 is a point lying on this. So let me take a point 0, 2 as a test point. It is not necessary that I have to take 0, 2. I can take any point here or any point here in this plane. I'm taking 0, 2 as a point, and it looks like 0 less than 2 is true. So since 0 less than 2 is true, I have to shade this region. So my shaded region will be this. Now how to interpret a graph? A graph is given, I would like to interpret this. first I should know what is the equation of the line. I'm going to do the reverse process. Earlier, the equations were given and we were tracing the curve. Now the graph is given, and now we would like to know what that inequality is. Here, the slope of this, if I'm taking two different points here, see, there are two different points, and the difference between those two, m, will be the difference between the y-axis divided by the difference between the x-axis. So here I have 80 and 0.6. So the slope will be negative 3 by 4, and the intercept here is 6. So negative 3 by 4 x plus 6 is the equation of this line. But it is a bold line, so it should be less than or equal to. We should know whether it is less than or equal to or greater than equal, but equality sign is there included. Now I have to take any test point and check whether it is true. This simplifies to 3x plus 4 equal 24. So it is a bold line. And when I substitute 0, 0, that 0, 0 belongs to this region. So I'm going to shade the region involving 0, 0. So this is below 2x plus 3, 4y less than or equal to 24. This is how I interpret the graph. Now let us see an application here in sales. An admission ticket to the stadium playing field is 125 and a ticket for the seat is 175. So there are two costs, one 125 and for the seats it is 175. The minimum requirement is 700,000 in ticket sales. So if X is the number of tickets sold for the playing field and Y for the seats, then 125X plus 125Y must be 700,000 because minimum sale must be this. And also there are some restrictions for X and Y. Since X and Y represents the number of tickets, it cannot be negative. It must be greater than or equal to 0. So we have these three inequalities. Say 125x plus 175y greater than or equal to 700,000, x greater than or equal to 0, y greater than or equal to 0. You can simplify this, or you can just take that equation and then we can construct that equation. You can even use your GeoGebra to construct this. And y greater than or equal to 0, greater than x greater than or equal to 0 will be the region above this. X greater than 0, y greater than 0. So this video helped us to understand how to shade linear inequalities using graphing calculator, without using graphing calculator, or using GeoGebra. Hope this video was helpful. Thank you for listening and thank you for watching.